Welcome to today's lesson. Today we're going to be talking about circles and line graphs. Circle graphs are pretty straightforward. Of course, it's in the shape of a circle, just like its name suggests. And inside that circle, it's usually split up into pieces, similar to this. It also resembles a pie, so sometimes a circle graph is also known as a pie chart. For the line graphs are similar to bar graphs that we've already studied, where there's still an x and y axis just like this. So here's our x-axis and our y-axis. We usually have numbers along this side of the line graph, just like that. And we also have usually time periods, days, or years along the bottom here. And a line graph oftentimes looks like a bunch of mountains, peaks, with some lows, and it goes one giant continuous line segment connected together just like that. And so those are your two main big differences between circles and line graphs. Circle graphs are also known to, the pie chart is also known as parts of a whole, and that's important as we look towards this more specific example. Pie charts, circle graphs always show parts of a whole. And so that means when we have a whole circle just like this, that's the total, that's everything all together, that's the whole thing. And if we have one whole thing, a whole circle, that equals 100%, and that's what your pie chart will look like, one giant empty circle. And of course, if you had a circle that was split equally in half on both sides, this would be 50% and this would be 50%. Those are the two parts added together, it equals 100%. And of course, just like in fractions when we reviewed it before, if I split it up into 4 equal quarters, just like this, each quarter equals 25%, just like that, or 1 out of 4, which is the same thing, it's just shown in a fraction form. That means when you add up all these choices together, that each one will equal together a total of 100% again. So that's the idea behind pie charts and how they show parts of a whole. Now let's take a closer look at our more specific example. We have a share of radio audience right here, and it's 12 years or older. So this is a survey done of people listening to the radio of 12 years or older. And their choices were adult contemporary, country, the CBC, talk, rock, and other choices that were possible. Now when you look at this chart right now, you can see that it's been divided into various sizes of different pieces. And so this chart is showing us the parts of a whole in this survey. And when we look closer at it, we can tell that the adult contemporary choice was probably one of the most popular ones, just along with equal to the other, because it took up the most amount of space inside this pie chart or circle graph. I can tell by its size that it equals a quarter of the circle, which equals 25% of the people who answered this survey of share of radio audience. 25% of them said adult contemporary. If we continue to look a little more closely, the other choice, other, is exactly the same size. It's a quarter as well, and so 25% of the people who answered this survey who said other choices besides the ones that were given to them also equaled a quarter of the circle, which is another 25%. And then if we look closer, we have these choices here: talk radio, country radio, and CBC radio. Those are 3 choices, and they all each look to be about 1 out of 10. They look pretty small, so we'll go 1 out of 10. 1 out of 10. And 1 out of 10. They all look the same size, so that's how I kind of know they're all 1 out of 10. And then 1 out of 10 equals 10%. And we have 3 of those, so another 1 out of 10 equals 10%. And another 1 out of 10 equals 10%. And so all we have left, we need to figure out what rock is. Rock's a tough one. I actually can't be that specific. Looking at it, I can't really have a guess. It's definitely bigger than 1 out of 10, but smaller than the quarter up here. It's smaller than this one, but bigger than this one here. So what is rock? Well, we can figure what rock is if you're rocking out, if you add up what we have already. So far, we have 25% plus 25 plus 10 plus 10 plus 10. If you add that up, that gives you, so far we have a total of 80%. So that means this whole thing, change my color so you can see it a little better. So that means this whole part of the circle graph, all these pieces added up together, except rock, equals 80%. So what does 80% have to add with in order so the circle graph equals 100% of the people that were surveyed in this year? What's the missing number? 80 plus blank equals 100. Rock must be, it has to be 20%. Rock has to be 20% because circle graphs always, always, always equal up to a total of 100%. All right, now let's take a quick look and a closer look at this line graph. The title of this line graph is Radio Listening by Teens. And our variable on the left-hand side right here is hour each week that those teens are listening to the radio. And down here we have a bunch of years. I apologize for the blurriness. This is 1998, 1999, 2000, 2001, 2002, 2003. And it's a line graph. You can probably tell by the obviously looking connected line segments all together right there. Now, when we look at this, we have an x-axis right here, and the title of our x-axis is years. Line graphs always measure how something changes over time. And in this one, in this case, we're measuring how the teenagers, when they listen to the radio, how many hours each week, and how that changes over the years. Line graphs will always have some sort of time variable at the bottom. It could be hours, minutes, days, years, months. Almost always, line graphs will always have how something changes over time. And then on the left-hand side, the variables here, we have how many hours each week. Something I want you to pay close attention to on this left-hand side here on the y-axis is this little squiggly symbol right here. And that's really interesting. You can see there's a red line already drawn there to draw your attention to it. Notice our numbers here. We have 11.5, 10.5, 9.5, 8.5, and all of a sudden there's no 7.5. In fact, there's no 6, 5, 4, 3, 2, 1, or 0. There is a 0 right here, but it's missing a bunch of numbers in between. Basically, this little squiggly symbol here on this line tells you that there's nothing in between there. So they were able to just squeeze the graph together to save some room. You're not missing anything. There's basically in the space below, down here, between 8 and 0, there's nothing there. So they squished it all together by using a little squiggly symbol that looks like this. And they put that in there. So that kind of gives you an idea of what that little squiggly symbol is, and that tells you why there's numbers missing on the side, because obviously we don't count 0, 8, 8.5, 9, 9.5. And so that helps you out. Now when you're reading a line graph, you have to connect the x-axis with the y-axis up here. Where they connect, that's going to tell you what the answer is. And so we have an x-axis. In 1998, you go up the line from 1998, and then you connect, that's where the dot is, and you connect it with the 11 right there, and that gives you, in 1998, 11 hours was listened to the radio each week by teenagers. So that's how we come up. These are called our plots. So we plot them down. We figured it out through a survey, and then we connected our plots together with a line, just like that. And so in our information, we found in 1999, about 11.4 hours was listening to the radio, and in the year 2000, about 10.5. In the year 2001, 10.0. In the year 2002, 9.5. And then in the year 2003, 8.5. So earlier on in the class, we were talking about upwards trends and downwards trends. That has to do with line graphs. When you look at this line graph and all the things it connects to, if you look at this line graph, what direction is it going? Is it going up or down? As the years keep going and adding up, what is the trend? Where's this line going? What prediction can we make? What is the trend amongst teenagers? Are they listening to more hours of music each week, or are they listening to less hours of music each week? If I asked you to make a prediction for the year 2004, which is not on this graph, where do you think the next plot would be? Do you think the next plot would be somewhere up here, 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 and then that gives you an idea. What is the trend? Where do you think the next plot's going to be in 2004? Well, if you look at the history of the past and where it's going, it's a pretty good indicator that this is a downwards trend. And this downwards trend is telling us that in 2004, there's a pretty good guess that the hours each week that teenagers listen to the radio will probably be somewhere between 8 and 8.5, somewhere in this zone of the graph here. I'm just coloring it in to give you an idea. Now that's not always exact. Sometimes it could go up, and sometimes there's no change. But if we had to make a prediction of what's going to happen next, there's a downwards trend in our graph. It's going down. And so in 2004, it's probably going to keep going down. Obviously, the opposite, an upwards trend. Let me just change colors here so you can just see a little more clear. If our data was telling us that it looked like this, we had a dot here, and then a dot here, and then maybe another dot up here, another one up here. That's an upwards trend. It's going up. And that's the difference between an upwards trend and a downwards trend. Tomorrow at class, maybe you can tell me some reasons why you think that radio listening by teens is consistently a downwards trend in 2004 and probably continues to be all the way up until the year 2013. Have a good day.